Here's an example of a function you've already met. It's the equation of the line of an equation, so that is mx plus c. So that's the same as when we were saying y equals mx plus c before. So for every value of x, we have to map that onto another. So e.g. The line for the equation 2x minus a third. So for every x we have to times it by 2 and then minus a third. So for 1 we would get 5/3 or 1.6 roughly. For 2 we'd get 3.6 roughly. For minus 4, for example, we'd get minus 8.3. Is that right? Yeah, minus 8.3. And we could, do any number we want. For 1,000, we'd get minus 2,000.3. Sorry, minus 1,000. So we can do all sorts. So I'm going to just plug some of those numbers in and draw and sketch the equation. So here's an important point. We don't have to have the same scale for both our axes. So here, this is 2, 4, etc. And then going backwards, 2, 4, etc. And then on the y-axis, we're going to go in jumping by 5s. That's minus 5, minus 10. So as long as along the whole axis you've got the same scale, they can be different for the x and the y, obviously. So let's put some of these on. So this is x, so this is the input, and this is the function. So for 1, I'll get 1.6, somewhere there, 2, 3.6, somewhere there, minus 4, minus 8.3, it's somewhere down here. So here's our line. This is just as before, and then for minus 1,000 it would be all the way down here. Alright, so that's one we've met before. So the line of an equation. So here it says y equals mx plus c is what we met before, and here we're just replacing that by calling it a function. Same difference. Cool. So now let's move on to think about some quadratic equations and what the functions of that look like. So by that I mean our first example would be x squared. So the fact we've got a number with an exponent of 2, that makes it a quadratic equation, and they all look kind of the same. And there's some information about that in the PDF that I've posted. Right, so we're going to sketch this equation, sketch this function, see what it looks like. So for every x we need to square it. So for example, so now then we're going to do for x's between minus 2 and plus 2. So let's just work some out. So minus 2 gives us 4, minus 1 gives us 1, 0 gives us 0, 1 gives us 1, 2 gives us 4. So in fact I'm not going to draw, let's not draw it like that. So you'll notice that none of our y values are negative, so we can give ourselves some space, draw it like that. There we go. Let's draw some of these on. So here, this is 0. There's 4 up here. Right, so first of all, 0 maps to 0. Minus 1 maps to 1, minus 2 maps to 4, all the way up here. 1 to 1, 2 to 4. So this looks a little something like that, and so any number in between would fall along this line. And here I'd like to note something important. So here if we look at y equals 1 for instance, that maps to two different x values, but that's okay because that still meets the definition of a function, which is that for every value of x, there's a single value of y, and that condition is met here. So let me just write that down. So same y-axis value for two x-axis values. That is okay. Still a function. Alright, so this is what we call, this is a quadratic function. So it looks a little something like that. So it's symmetrical in this case around the y-axis, around 0. So now we're going to look at a slightly more complicated one. So how about fx is 3x squared plus 4x minus 1. And we're going to do that for x between -2 and +2 as well. So here that means that x maps to 3x squared plus 4x minus 1. And I've worked all those out. So if it's -2, that gives us 3, minus 1 gives us -2, 0 gives us -1, 1 maps to 6, 2 maps to 19. So again, let's draw what it looks like. So again, we do have things under 0. Let's rethink. Oops. Not doing very well here, am I? There we go. Yeah, let's just extend that a bit. So here we've got 2 minus 2. And then here we're going to go all the way up to 19 here. So we're going to go in leaps of 5. This is 20, 10. And so there's -5 down there. Okay, so -2 on the x-axis maps to 3, so that's about here. -1 maps to -2, so that's about here. So I'm just sketching it casually. It's not, I'm not trying to get it perfect. Excuse me. 0 maps to -1, about there. 1 maps to 6, that's about there. 2 maps to 19, that's up here. So here we've got a function with a similar shape to it. So you've still got this symmetrical curve with a turning point. So quadratic functions all have a single turning point. That's what I mean by turning point. So it goes, the numbers are going down, and then around here, for x equals 0, I think that's always true, we have this turning point. Okay, so there are a few more examples of functions, and I said if you want to learn more, you need to go and learn more about these quadratic functions in the PDF that I posted.